In this video, I'm going to show you how to create a FreeRTOS embedded system project using CubeMX software. I'll also be including a couple of tasks and show you how to execute it. All right, so first thing I would do is go to File, create new project. Under the new project, I would go to the board selector because it's a Nucleo board that I'm using. And mine is a Nucleo F103RB. Um, and I would just double click on this. It asks me to confirm if I want to initialize all peripherals in their default mode. So all the peripherals that are connected on the Nucleo board would be initialized as they are. So I would just select yes for now. The Nucleo board comes with one LED and a push button. So you can see the push button is connected to pin number 13 of port C, and the LED is connected to A of pin 5, or pin 5 of port A rather. And then we've got the debug port available here, and then there's the UART port, UART2, that is connected through the ST-Link on the Nucleo board, and it shows up as a virtual COM port. So we'll make use of this to show that the tasks are running. All right, so I'll leave everything as is, that's fine. I will head into the middleware, select FreeRTOS, and enable CMSys version 1. Okay, so I would directly hop into the tasks and queues section. There's a default task that has already been created by CubeMX. I'm just going to rename this to my task 1, and the function name would be start my task 1. So it's, and the priority is set as OS priority normal, so I would leave as is. All right, jump back again into tasks and queues, add another task, call this my task 2, and start my task 2 as the handler. The priority here is idle. I would change it back to normal because I want both these tasks to be at the same priority. I would leave the clock as is, or rather I would just change this here. It's not really mandatory, but you could use whatever settings you want to. Under project manager, I would call this FreeRTOS 1. Right, so given the project a name, I've selected the workspace location. I want to use the advanced project structure, and it automatically picks up where the code files will be generated. I'm using True Studio, so I'll select that, and everything else looks good, and I would just click on generate code. Oops, sorry. So yeah, this is one warning that CubeMX gives you, that is the time base that you're using for your in your firmware should not be SysTick when you're using FreeRTOS. So I do not want to generate the code. I would jump back to pin and configuration, go to the system core, go to sys. I'll go to sys and select anyone. So I'll just select timer 1. Go back to project manager and click on generate code. Once the code has been generated, I'll hop back into uh, True Studio and import my project here. So I would select existing projects into workspace, and it would ask me to browse where I have my project saved. So it's under FreeRTOS. Okay, it has recognized the project there, and I would just finish. Click on finish, and there you go. So all the source code for us lies under the core folder, the includes and the source files. What we're interested in is in the main.c file. All right, so This is what CubeMX has done for us. It has created two thread IDs, then it instantiates two threads using those thread IDs, and then finally creates the task from those threads. Finally, it starts the kernel, and that is when these tasks start running. Okay, so if you jump back to the handler function, what I'm doing here is not really recommended because I'm having the two tasks uh, use the same resource without um, any safety checks, so to speak. And this is basically a race condition that's going to happen between the two. So that would be HAL transmit. Okay, UART2 task 1. So that's 1, 2, 3, 4, 5, 6, 7 bytes. Delay. Okay, and I would just jump back to task 2 and paste that here, make this tasks 2, and actually just increase the delay to, let's say, 1 second for this task and 2 seconds for the first task. All right, with that done, I would just click on debug. What now is happening is that it's at the breakpoint at the start of main. I would just hit resume and the function should now be running. I have real term running here, so you can see both the tasks are in fact running. You have task 1 coming from the first task and task 2 coming from the second task. And that is how you implement multi-threading in your embedded systems. In my future videos, I'll show you a lot more that goes on that you can use in your FreeRTOS projects. Thank you.